Hello everyone. Today, let's learn about cast-in-place reinforced concrete floor slabs together. In the previous lesson, we mentioned that, according to different construction methods, reinforced concrete can be divided into three types: integral cast-in-place, prefabricated assembly, and assembled integral. Firstly, let's understand the concept of cast-in-place reinforced concrete floor slabs. What is cast-in-place reinforced concrete floor slab? Setting up formwork at the construction site, bending steel bars, pouring concrete, curing, and finally removing the formwork to form the floor slab. Advantages: free molding, good overall integrity, high stiffness, and good seismic performance. Disadvantages: large on-site wet work, high template usage, high labor intensity, multiple processes, long construction period, and significant seasonal influence. Scope of application: high-rise buildings with high overall requirements, irregular floor plans, dimensions that do not meet modular requirements, or floors with many pipeline crossings. Widely used. Next, let's learn about the types of reinforced concrete floor slabs. Cast-in-place reinforced concrete, according to different stress and transmission conditions, can be divided into floor slabs, beam and slab floor, beamless floor slabs, and composite floor slabs made of profiled steel plates. First, what is a plate-type floor slab? When the room span is not large, there are no beams in the floor slab, and the slab is directly supported on the surrounding walls. Plate-type floor slab. Flat bottom, easy construction. Force transmission, slab to wall. Suitable for small span rooms, such as corridors, toilets, kitchens, and so on. Plate floor slabs can be divided into two types, based on different forces: one-way slabs and two-way slabs. One-way slab refers to a force applied along the short side direction, but two-way slabs refers to a force acting in both directions. So, how are the one-way and two-way boards divided? If the ratio of the long to short sides is greater than or equal to 3, it can be calculated as a unidirectional plate, subjected to force along the short side direction. If the ratio of the long to short sides is less than or equal to 2, it can be calculated as a bidirectional plate, subjected to forces in both directions. From the graph, we can see that the ratio of the long to short sides of the left span is greater than 3, calculated as a one-way slab. The stress steel bars are arranged along the short side direction, while the distributed bars are arranged along the long side direction. If the ratio of the length of the second span is less than 2, it shall be calculated as a two-way slab. The stress steel bars are arranged in two directions simultaneously. Second, what is a beam and slab floor? When will it be adopted? When the floor plan size of the room is large. In order to avoid excessive span of the floor slab, we can set beams under the floor slab to reduce the span of the slab. Its transmission characteristics: the plate transmits force to the beam, and the beam then transmits force to the wall or column. Suitable for rooms with larger spans. According to the arrangement of beams, beam-in floor slabs can be divided into single-beam floor slabs, double-beam floor slabs, and wall slabs. Let's first understand single-beam floor slabs. What is a single-beam floor slab? When the horizontal span of the room is not large, we only set the beams along the horizontal direction and directly place them on the wall. From the figure, we can see that, in general, we refer to the short side of a house as the horizontal direction, and the long side as the vertical direction. When the horizontal span is not large, we arrange the beams along the horizontal direction. Its transmission characteristics: the plate transmits force to the beam, and the beam then transmits force to the walls at both ends, suitable for rooms with small horizontal spans, such as teaching buildings and office buildings. Let's learn more about double beam floor slabs. What is a double beam floor slab? When the plane dimensions in both directions of the room are large, we need to set beams along both directions below the board. From the picture, we can see the horizontal short side direction and vertical long side direction dimensions of the house are both very large. So, we set the main beam along the horizontal direction, short side direction, and the secondary beam along the vertical direction, long side direction. Its transmission characteristics. The plate transmits force to the secondary beam, which in turn transmits force to the main beam, which in turn transmits force to the wall or column. Suitable for buildings with larger floor plans, such as teaching buildings, office buildings, and small shops. The beam is supported on the wall in order to avoid crushing the wall and ensure the transmission of loads. There should be a certain support area at the support points of the beam and wall. What can be done to ensure the support area? By specifying the minimum length for beams to be placed on walls. When the height of the beam is less than or equal to 500 millimeters, the minimum resting length of the beam is 180 millimeters. When the beam height is greater than 500 millimeters, the minimum resting length of the beam is 240 millimeters. However, when the load on the beam is large, the supporting area of the wall is not enough. We can set up concrete beam pads, which can be prefabricated or cast in place to prevent local compression. The first picture is a precast concrete beam pad, and the second picture is a cast-in-place concrete beam pad. From these two pictures, we can see that the contact area between the beam and the wall was only a small part before, but by setting beam pads, the contact area between the beam and the wall has increased. Through the formula, it can be known that the average pressure per unit area is equal to the force divided by the contact area. As the contact area increases, the average pressure per unit area decreases. In this way, the beam is less likely to crush parts of the brick wall. Wall slabs. The last type of beam and floor slabs. Wall slabs belong to the category of beam and floor slabs, and are a special arrangement form of beam and floor slabs. But when should we use wall slabs? When the room size is large and close to a square. Arrange the beams in both directions at equal distances, without distinguishing between primary and secondary beams. Its transmission characteristics. The plate transmits force to the beam, and the beam then transmits force to the wall or column. The layout forms of waffle slabs include orthogonal upright placement, orthogonal oblique placement, and oblique intersecting oblique placement. Orthogonal represents two directions, where the beam is perpendicular and orthogonal. Third, beamless floor slabs. Beamless floor slabs refers to a slab that is directly supported on a column, without beams. The beamless floor slabs has a flat ceiling, large indoor clearance, good lighting and ventilation, and simple construction formwork installation. Its transmission characteristics. The board directly transmits force to the wall or column. From the picture, we can see that this is a column, with column caps and support pallets placed on top of it, supporting the slab building together. So why add column caps and support pallets? Because the slab is directly supported on the column. The support area between the slab and the column is only the cross-sectional area of the column top. If the load borne by the floor slab is very large, transferring such a large load to the column can easily compress the column top. In order to increase the support area of the plates and columns, and reduce the average pressure per unit area, We need to add column caps and support plates. Lastly, we will learn the composite floor slab with profiled steel plate. From the figure, we can see that a profiled steel plate is laid on top of the steel beam, and the profiled steel plate is used as the bottom formwork. Then, concrete is poured on top of it to form the overall composite floor slab. Concrete and steel lining plates are poured together and subjected to joint force, with the profiled steel lining plate serving as a permanent formwork. Composite floor slab with profiled steel plate has high bearing capacity, rigidity, lightweight, and fast construction speed, but it requires a large amount of steel, is expensive, poor fire resistance, and corrosion resistance, suitable for large space buildings and high-rise buildings. In this lecture, the introduction of cast-in-place reinforced concrete floor slabs has been completed. Thank you.